So for this example, I will be using the data set with houses sold in Ames, Iowa. So if you click here on the data editor, its title is Dataset Ames Houses, and you can access it through the link in the video description. So before running a regression, it makes sense to quickly check what's in this data. And we can use a shortcut SU for summarize command in Stata, highlight it, click on that button, execute selection, and you can see from here that we have up to 3,000 houses. So I just picked a few variables. We have sale price of the house and lot area, overall quality, and year sold. So I just have 4 variables just for illustration. Of course, you can add more easy, it's not a problem. And it's very easy to run a regression in Stata. For that, again, you can use a shortcut reg or regret. So what you just need to do, you need to highlight this line. And in that model, I want to look at how sale price depend on these 3 variables: lot area, overall quality, and year sold. And of course, again, you can add more variables without any problem. So you highlight it, click on that, execute selection, and already you got the results of this regression, of a linear regression. And a few things which are worth exploring here. They deal with how you interpret coefficients, of course, and a little bit about the goodness of fit and about statistical significance. So first of all, let's look at the statistical significance, and we can check the adjusted R² here. And you can see that even this simple model with just 3 variables, right? We have a constant which is added automatically, right? But otherwise we have just 3 variables. It's already explained as much as almost 69% of variation in the sale price. And it's quite successful given the simplicity of that model. So the next thing that practitioners look at when they run a linear regression is statistical significance, and it's easy to do by checking the t-statistics, right? That's the first thing you do. And you need to check whether a simple rule of thumb holds here. So if a t-statistics in absolute value is more than 2, this coefficient is statistically significant. So here we have the lot area and overall quality are statistically significant, but year sold and constant are not statistically significant. And in principle, of course, you always should keep intercept or constant in your model, even if it's not statistically significant, because it guarantees the adequacy of our statistics based on this linear regression model. So remember that this rule of thumb implies that this statistics is more than 2 in absolute value. So if I had here, for example, minus 2.86, it would also be statistically significant, right? So we drop the sign and we compare it against 2, and in this case it's statistically significant. And a more subtle definition here will be to look at the p-value, right? It's next to t-statistics here, and you can see that if t-statistics in absolute value increases, p-value at the same time decreases. So for example, p-value for the statistically significant lot area and overall quality, it's actually less than 1%, but for the other 2 coefficients, it's actually much more than 10% here, right? And usually we have this 10% rule, right? So if p-value is greater than 10%, then we say that coefficient is not statistically different from 0, or it's statistically insignificant. For coefficients which are statistically significant, you can easily interpret the results here. For example, again, we just pick these first 2 which are significant. And for example, lot area here means that if the lot area increases by 1, then the price of the house increases by $2, which is of course probably not so much economically significant, but it's highly statistically significant. At the same time, the overall quality runs from 0 to 10, right? So the best houses would have overall quality of 10, the worst houses would have overall quality of 0, and each additional improvement in the overall quality adds the substantial $44,125 to the price of the house. And of course, you realize if you add more variables here, which you can easily do, then this most likely will decrease, right, this quantity, because overall quality captures a lot of things like size of the house, or number of bedrooms, or number of bathrooms, and if you keep including them, this overall quality will become less and less significant. To practice these and many additional Stata tools, please check out the description for a coupon code to my new course, Jumpstart Stata in 2 hours. Thank you.